Okay, this video is going to help you finish the worksheet, slope worksheet number 1 here. We did this yesterday, but some of us may need some more additional help. So we're going to review how to find the slope given the line. So remember, the number one thing to remember is your definition of slope. And slope is rise over run. We can also think of it as delta y over delta x. Remember, delta y and delta x mean how much did y change? How much did x change? So we're looking for that information from the graphs. So remember, in order to find the slope of a line, we need to figure out how much it grew from one point to the next. And so I have to, number one, find some points. So I see a point that looks like it's approximately right there, and there's another point right at the axis right here. So first step is to find a pair of points. Any pair of points as long as they're exact points on your graph. Now I'm going to walk the slope and find the rise and the run. So I follow the grid lines and I go up and over to my point. I draw in a slope triangle. Now I count the rise and the run. The rise here is 2 and the run is 1. So the slope for line number 1 is 2 over 1 because 2 is the rise, 1 is the run. That simplifies to just 2. So my slope for line number 1 is 2. Try it again for line number 2. Find those 2 points. Looks like one point is right about there. Another point is here. Okay, I'm going to walk from one point to the other, find the rise and the run. So let's see, I'm going to actually go down and over. A couple of questions were asked yesterday that were really good questions. If we should draw the triangle on top or on bottom of the line. For instance, we could draw this green triangle. It still meets the requirements of following the grid lines to get from one point to another. Notice that your rise will still be 2, whether or not you drew the green or the red triangle. Your run will still be 3, whether or not you drew the green or the red triangle. So the slope is still going to be rise of 2, run of 3. Rise of 2, run of 3. Or 2/3. No matter which way you do it. Now what's really important here is that we see that the slope is not only 2/3, it's actually negative 2/3. Because the line is going downwards when I read it from left to right. I also can see that if I start at the first point and go to the second point, meaning the first point on the left and go to the second point to the right, I will have to go down 2 and over 3. So we really should think of this 2 as negative because it takes me going down in order to get from the first point to the second. So the slope here is negative 2/3. That negative is really important. Pause the video here and try to do lines 3 and 4 on your own. And keep going. When you get stuck, check in with the video because I will walk through every solution here. So pause it now, try to do the rest of them on your own, but restart the video when you get stuck. So here's the solutions to lines 3 and line number 4. Okay, line 3. Looks like there's a point right on the axis and there's a point up here. Take the rise of 1 and a run of 2. So 1, 2, to get from one point to the next. The slope is 1/2. I check and make sure the line's not negative, but it looks like it's positive because it is going in the upward direction from left to right. Now let's take a look at line number 4. There's a point right about here, and there's another point right in here. Okay, this line is definitely falling, and it is falling 3 and going over. So my slope is negative 3 over 1, or that can be rewritten as negative 3. So there's your solutions to 3 and 4. Once again, try the next problems on your own if you haven't already. Check back here for the solutions. Here's line 5, 6, 7, and 8. So let's see, line 5. Looks like the points are one after the other right away. So I have only a step of 1 by 1. But once again, the line is falling, so it's going to be a negative slope. It's going to be negative 1 over 1, which is the same as negative 1. What's really cool is I could have picked 2 points that were really far away and I'd still get the same answer. These two would have a fall of 3 and a run of 3, But negative 3 over 3 is also negative 1. You can verify that in your calculator or think about what is 3 divided by 3. That's 1. So it's going to be a negative 1 slope either way. Let's try this next one. Let's pick this point and this point. Looks like it has a rise of 2 and a run of 2. 2, 2. So my slope is 2 over 2, which equals 1. This is a positive 1 slope because, once again, we look whether or not the line's going up or down. So it's always important to think up or down. Line 7 and line 8 are complicated ones, okay? But the process remains the same. I pick 2 points. I calculate the rise and the run. Let's see, the rise is 2, but there is no run. We don't go to the left or right at all. So my slope is 2 over 0. If you remember in class yesterday, we talked about how this means the slope is undefined and is not legal to divide by 0. This next one, though, is similar in that it has a 0. In this case, the run would be 2, but there is no rise. So my rise is 0 over my run of 2. This is defined. You can do 0 divided by any number, and you will always get 0. This has a slope of 0. These are important special ones to remember. So they look different than other lines, and they have different slopes than other lines as well. But the same process applies. So remember, now you're moving on to the next video, and you're working on the next worksheet that will be handed out to you when you finish this one. So ask your questions of Ms. Rice if you have any.